Jim, everyone, and welcome to today's live stream. I'm trying to put this up there. Uh, Minimize this. Yeah, so let me see what it looks like now. Let me also have a look at. I want to see what the audio sounds like before we get started. Okay, looks like the audio is loud. Okay, I'll tone that down a bit. Alright, thanks, man. Okay, so we are good to go. 1 minute. Let me just share copy link. Uh, I want to share that we are live. So again, 1 minute. Let me quickly do this. And we should be ready to go. Emoji do I want to use? Let me use this one. Use this one. Okay. So yeah, jam guys. We are here to talk about what talking about again? AccountsDB and accounts, essentially, the whole lot of it. So I think last week we were able to cover. We were able to cover last week. Let me check. Last week we were able to cover. It's not. I think it's not accounts. What happens when you create an account? Ownership, then writing to an account, resizing accounts. Then we started to look into um, accounts DB, reading the article from Anza, the accounts DB article, this one. Yeah, and we'll be picking it up from the same place this on today's live stream. And what we'll be talking about today is, let me just give you, okay, before I start, let me set up something that will be useful along the way, because we want to be able to test some things in the architecture of the how it says it should work, basically. So we need some accounts to test some things, and I want to quickly set up those accounts before we get started. And I think it was in accounts test. Yeah, let's code accounts tests. Yeah. So I want to do. What's my terminal? What I want to do now is I want to create, I think, maybe 5 accounts or something. So I can grind those, this, can grind those with Solana, Solana Keeper, Solana Keeper, sorry, Solana Keygen, grind, uh, starts with, I want to grind account that just start with A, and I need 5 of them. Let's see AR. 5 accounts that starts with AR. Ignore case. I think it's ignore case. Ignore case. I think. So I don't want to. I don't care if it's capital letter or small letters. Just I don't want it to be case sensitive essentially. And we finally wrote 5 accounts that starts with AR, 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 AR. So 5 accounts. And what I want to do is let me send some tokens to these accounts to create them essentially. Uh, Solana transfer, yeah. You transfer 0. Let me do Solana airdrop first. If I can be airdropped, airdrop 4, and it should fail. Recently, DevNet has not been giving out airdrops. Let's see if it works this time. And failed. One more try. And it's failed. All right. So I think I still have some balance, or can I let me get from faucet just to top up my Solana faucet. Solana DevNet faucet. Solana DevNet faucet. And I want to Solana address. Get my wallet address here real quick. Let me paste the first one in here. So let me get this one out. And I want to request for 5. So connect my GitHub. Okay, connect my GitHub, paste in the wallet address and request for 5. So s'il vous plaît. Oh, I'm not showing that, sorry. Yes, doesn't matter anyway. I'm just requesting a drop. So now we've gotten 5 soul, hopefully that went through. So from that balance, I want to do, what am I doing? Okay, no problem. Just get it again from here. I'll do, can I even batch transfer? Solana transfer 0.5. So I think it's amount, address before amount, I think. And paste in the address. Then we'll do allow, what's the flag again? Allow, I can't remember how the flag is. So let's just go, yeah, allow unfunded recipients. Allow unfunded. Allow unfunded recipients. And we go, yeah, that's the first one. Let's do for the second one. Same story, go up here and paste it. V, yeah, yep. Second one, for that one to the third one. So the third one, so let's go up. I mean, that way I could just batch send this. Space that here, move the JSON. That's the third one. Let's go for the fourth one. Okay. But I'm excited about what we're gonna do today, guys. Yeah, let's see how far we go. The fourth one, and there should be one more. Yeah, alright, this is one more. And there should be one more here. And we just do, yeah, up to, okay, we were able to airdrop all five wallets. Okay, so let's see. I'll leave that for now, and let's just continue with the uh rest of the things we're talking about before we get back to that. What? Solana config get devnet. Okay, cool. Nice. Itchy. Right. So let's get back to within the uh, within the article. What is AccountsDB? We covered most of this last week, but let's see how far we can see. All right. It says it on the screen. AccountsDB is a database of accounts stored by validators and used to track accounts data. Right. So one thing I want us to know is, okay, it's not so much as it's the database, but not so much as a long-term persistent database. Not, no, not so much as that. But we're going to get that. So I'm going to get to that a bit. You could say you could query accounts DB for state of an account up to, let's say, maybe 2 5 slots, 10 slots maybe. But what about if you want to get old state of the blockchain, like all the transactions that this account has done for like 12 years or 12, sorry, no, that's not 12 years, like 12 months or like 4 years ago, all the transactions that this account has done. AccountsDB will not be able to provide that for you. That you get that from the ledger state. Let me see. Is it in CD document, CD agave ls? Then you should have a, yes, ledger. Ledger is a ledger tool. In one of our next series, we might talk about that. Well, after AccountsDB, I think the closely relatable one I would like to talk about is the bank. Where's the bank? Where's the bank? Yeah, bank server, bank interface, bank's client. Then so banks. What is bank about? But it's interesting. We might talk about banks a little bit in this AccountsDB series because they go and in fact every part of the the validator is connected in one way or the other. So but we'll talk about them when we get to that part. We have voter from Alpenglow, that's for another day. Yeah. So yeah, AccountsDB is a database of accounts stored by the validators. So it essentially helps you to keep track of what accounts were modified in this slot. So in some slots that the validator is tracking, what accounts were modified, what accounts were written to, and all. So you can get all of that from AccountsDB. So you can quickly get the current state of an account with AccountsDB. Yes, so what LAMP ports, what data are stored. And we've already established the fact that what kind of data needs to be stored. And we talked about, okay, kind of data that will be stored inside of it is this, essentially what is stored in an account and some extra. LAMP port, rent a porch, the owner, is it executable, the data length, the rights, version obsolete. So there's an account header and there's the data, like this growable data. Because this data is data of an account is growable, right? It's not doesn't have a fixed length. So you need to know how do you track, and you're storing it in a way that you need to be able to query it. Yeah. So you need to know the length of the data and the length of the header and the size of the header. So the header might be static, which should be static. Then the data is growable. So inside the header, you would have the length of the data. So that's why they are uh stored sequentially here. So I have the account header, then the account data, padding, account header, account data, padding, account header, account data, and account garbage. So this is the full account as in a file. It can be read like so. But how what does the header actually look like? We get so we already talked about snapshots also. We said for a new validator to join the network, he must be able to catch up with the current state of the network. Yeah. So that's what snapshots are for. Snapshots helps a new validator catch up with the current states of the network. You'll be able to know the current state of the accounts that will be modified currently in that slot, about the specific slot. So you get that from existing validators in the network, yada yada yada. We talked about that already. Mm, so this is below is a diagram of a standard Solana snapshot at slot. The two corporate highlighted. Yeah. So let me show proof that this is be correct or true something. We might also maybe get into it later in the course of the video. But let me go into the I'll go into test ledger. All right, so there's a test ledger, all right, in my on my PC because when I run Solana test validator, these are the files that the validator actually are persistent to disk. So I'll go to see the test ledger here. You know how Solana test validator works. Yeah, just right. If you have Solana CLI installed and the test validator with it, so Solana the test validator, I think data like so. Yeah. So it spins up it tests a local net version of Agave that you're running. The identity, genesis hash, shred version, your gossip address, your TPU, JSON, and all and all and all. So I'll close this now. So this is like a validator, a test net validator, a local net validator running on my PC. So I'll close this and let me show you what I wanted to actually show you. See the test ledger. Let me let's see ls. Yeah, so let me open this file, this folder rather. If I open this folder, you'll be able to see something similar to what we saw in that doc here. You see we have accounts here. We have you saw snapshot. So this is like a snapshot of the previous states, maybe the initial states where I downloaded Solana test validator or something. So there are like two snapshots there for you to get the actual state of the blockchain. This is a tar.gz file, tar.zst file. This is standard library. This is standard, what am I saying? So snapshot are built and downloaded as tar archive compressed with the Z standard format. So file extensions are usually .tar.zst. So we can see that here. This was yeah. So this is like the instance where my test validator got a snapshot to start working off of. Yeah. So when we go into accounts, let's now see. It says accounts are stored. So this one is the snapshots. We saw that already. Now we see accounts are stored in accounts folder. Like account files are stored in account folder. Inside the account folder, I should see something like 196 blah 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 dot blah blah blah. Let's check if we actually have that. And let's check our accounts folder. We have run. So when for a session or snapshot accounts, let's check for a run. And you see there's a 346.3, there's a 421.1. I will want to assume this is the slot number. Maybe may not be, but let's see. We get to that. Dot three might be the bank Fox. We've not talked about banks at all. So let's just assume so this is like one file. of accounts for that particular slot. So I can open this with, I think X editor works. Yeah, and you'll be able to see the big file, but essentially be able to see data that is data that's stored. All the accounts, these are accounts, but like we said, the accounts are bytes. Everything is written in bytes. So we would have the header. So yeah, these zeros here, this padding is, I think this padding again. Then some more padding. No, this is not padding. This is not padding. So like they are padding to separate different, like we saw here. Yeah. The what is that? Yeah, like we saw here. We have account header, then the data, then padding, account header, data, then padding, account header, data, garbage account. So we may be able to, at the during the course of this video, try to load this account file and try to make sense of it. So that's basically the idea. Yeah, we want to test that what the things that the library says actually exist, the thing that the article says actually exist. So these are a lot of accounts here inside the account files. So we're making progress, more progress than what we were last week. Yeah. So there's a lot of accounts here for a local test editor, and another slot we have another account file. Yeah, so there's another account file that can be loaded. But yeah, interesting. We will get to loading it hopefully. So if you check snapshots also, you also see similar stuff. So for snapshot slots, see you check these snapshots here for slots 10303, the account part 10303 is also a file. That one doesn't have an extension because that's the resolved, that's like the resolved file for that slot. So it's not like a fork. We're not talking about forks yet, so don't let me get into that yet. So, but essentially, let me just throw in a teaser. Essentially, the state of a blockchain is not it's not yes or no. It's not like we just know the state of a blockchain once people. The reason why there are forks is okay, you can have two different slots data that were voted on or that gets to you as a validator. Why? Because other people are voting also, other people are also part of the network, and data needs to be transmitted over from one validator to the other validator, yeah. And if data is stale or some data is missing or something, another validator might not be able to know the updated state of an account, but treat it as final because um he didn't get anything over gossip to say this file was updated. Not even over gossip. He didn't get anything to know that the file was updated because he was not the one validating transaction at that moment. He was not the leader at that moment. So the information, the data did not get to the validator to know that okay, a particular account was updated. Then it starts speaking when it is done to maybe be the leader. It now picks from its own account DB to know the current state of the account, then starts writing on top of that. It will be looking at stale data here, and it will create a new slot on top of that one. So now we have a slot that was created from old data, basically. So that's why there can be forks. So there's a different fork of there might be slot 122 and you have fork A or fork B, fork 1, fork 2, fork 3, a lot different slots, different forks of a particular slot. And the one that the majority of network votes for and validates is what will actually be resolved. Well, when we get into banks and bank forks, we can talk about that. But for now, we're on accounts DB, and let's do some accounts DB stuff. Mm, okay, I hope it's clear. It's clear. Just let me know in the chat if you're good or you want any questions. You have any questions you want me to answer? Okay. Account files. We just looked at account files. So they're previously called AppendVex, but now it's account files. We just saw some account files. So reading the data involves, if you have data from the snapshots, you would first decompress it, that's to unarchive it, then load it into memory via a mmap score. So what that does is, instead of, if once the account file is downloaded, has been unarchived, instead of opening the file every single time you want to read from the file, which might have overhead, this is an optimized way to have a map about what happens, what's inside the file. Like have a map to that file and read from that map instead of opening the file currently. So you're not going to be doing a file open event. Essentially, is what mmap syscall does. I think I'm correct. All right. So it loads each account file into memory via mmap syscall, and it reads the entire length of each file, organizing into structures, and so on, so on, so on. I forgot about this. We talked about this pseudocode last time, and I think we also did an example of what casting would look like. Yeah, let me see if I can pull that up again. Did we some new accounts? Did we some new accounts? Was it here? I don't think it was here. Let's see. Let's see. Leave arrest, state arrest, test arrest. I don't think it's so where was it? Where did we write that into? Let me try if I can. Let me see if I can get it. CD data first. Let's see the document. Mm, CD test account. Let's see accounts. No, 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 it's not account test. CD. Just this. Let me check. Uh, let me see over here. My file explorer. I think I should be able to get the name of the file from my file explorer. Okay. 1 minute. I'm trying to look for the where we wrote the code uh for what was that again? Forecasting, yeah, forecasting data type, just like a pseudocode, Python, playground. I think it was playground. Yes, playground casting. So cd playground casting code. Aha. So this was the one. So this was the one. What we did there was we tried to add some data, like we saw. We were trying to explain what's happening here. Says it first gets the size of the header file of the static values. It's as header, and it loads them. It loads a specific static value from the mmap. So let's assume, and it needs to know the offset size, then the static value type. So it needs to know. Let's assume this is a very big file, bytes, a lot of bytes everywhere. Yeah. So assume that's what happens. So it needs to recreate something. In our case, it will be, in this case, it is static values, but to be an account essentially. So it needs to recreate something, and something would have the pub key, the lamp ports, or whatever, but they are stored as straight out bytes in memory. So we try to do something, then cast from bytes. So just pour in these bytes into a function called cast from, and what that does is that's the bytes that were sent to it, and just directly casts to unsafe. Is unsafe by the way, but there's the safety. The reason why unsafe is safe here is that we have what our struct is tightly packed. So RPRC gives us, and using byte arrays here, we know that the size is deterministic. So we have a size of 7 here. It's always going to be 7. So we can we can read from, and now since it's just seven, and we are ensuring here also that it must be a size of seven. If you are passing bytes that is not of size seven here, we cannot read it for you because the only thing that this can contain is 7 bytes here. So essentially, we're just casting it, we're reading it as something, but it's just plain old bytes here. So if I run this code, let me run this now, you should see what's the error? Oh, not this one. Let me rename this to be a TypeScript file, even though it's not a TypeScript file. Yes, leave it TypeScript. Let's assume it's TypeScript. Comment this out, then main RS. So main RS now. Let's run you again. Yeah. So now we have something struct, and we can do second is 20, first is, so let's do, yeah, first is 10 and 4, then third is 5, 6, 6, then. But let's assume these are actual numbers because what this is a U16, this is a U32. Let's see if we can read them as okay. Let's first item is something, some, not some data, something, something dot first, yeah, and we can make that into a, so the first is a U8, is a U8 actually, so we first is a U16, so we can cast that to U16, and we do U16, then from early bytes, assuming they are stored in little endian bytes, and we do something that first to, we'll stop that one, we borrow, we needed uh LE bytes, not LE bytes. Let's borrow that. Move. Well, numbers don't move actually, but let's still borrow it. I don't need to borrow it. All right. So first item, and we want to do second item also. Second item is a U32. So we do a U32 from LE bytes. Then it'll be something that's third. So let's see. You can print that also. And second, let's see, and first is, while second is okay. I know we're going over this again, but no problem. First item, second item. So if I save this and we try to run it one more time, let's run it one more time. Then we'll see first is 1034. That's if you represent, if you represent this in as a U16, if you represent these 2 bytes as a U16, you would have the value is actually 1034. And if you represent this 4 bytes as a U32, the value will be 16816 blah blah blah. So you understand what we're aiming for, yeah. So yeah, so that's something similar to what what this is doing. It casts the bytes that it read from mmap, and it knows what we want to cast it at, what we want to read it as, then basically just appends it to AccountsDB. And the account index, we also talked about the account index. I feel like I'm going over these things I've talked about already. But the account index essentially helps us to quickly locate where an account is on the in the account file. So if in a slot you touched an account that is zero, let's say we touched one of these accounts. Let me close this. We don't need it. Okay. don't need that. We don't need this anymore for now. Let's say we touch this account, there'll be an hash map that would be hash map of the pub key to a vector of the slots, file ID, and the offset. So we will be able to easily know where this pub key data lives inside the account DB with the account index. So it will quickly know if this slot is 19 blah 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 blah, it quickly find slot 19 blah 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 blah. And the file ID, this is its file ID. Then it knows we have to know the offset. Like we said, everything is stored in bytes, like this one. So if the account I'm looking for starts at offset 20, 1, 2, 3, 4, 5, 6, 7, 8, yeah, let's start from offset 10. This is where the account starts reading from. Offset 10 is 0, 1, 2. Yes, offset 10 is this. So it starts reading this from offset 10 and it reads up all to the size of uh size of static values. Then it knows data is appended to the rest of that static values. So it just quickly know where the accounts live here, and how to read the accounts effectively. Mm, Okay, so when reading accounts for a given pub key, the general flow would be check the RAM index first. Then if it doesn't exist in the RAM index, check the disk base index. And if it doesn't exist in the disk base index, then throw the error that the account does not exist. What this RAM index is actually into three things. Okay, I think there are three things. In the RAM index, there's the read cache, there's the write cache, and there's the account index itself. Yeah, so this is one of the things we are going to. There's a theory that once it reads account, once it you ask it for an account, the state of an account, it reads it first, it reads it, and if it finds it, it keeps it in a cache because you may want to read the account state again in an instruction. You may want to read the account state twice now, or you might want to read the account state again. So it keeps that in a cache. Yeah. Then once it writes to an account, it also keeps that in another cache called the write cache. So we have the read cache, we have the write cache, and once enough it's rooted, once the slot is rooted, I mean it is definitely confirmed that this slot is cannot be replaced. This slot is final. It cannot be, if the slot is not a fork, it is an original slot. Let's say all the transactions inside have been voted to be correct. So if enough vote has gone over the slot and see that the slot is rooted, it now moves that into the persistent store of the accounts DB. So that's when it now writes a new file, opens a new file for all the accounts for that slot that were touched in that slot. Yeah. So the read cache, the write cache, I think there are three, but I think just two that I remember now. So I'm going to test that. Let's get into reading accounts first, see if we will still remember all of that. If it's not there. Reading account. If we want to read the data from a specific account and we know the account pub key, we find its location in the account file by looking up its pub key in the account index. Yeah. So it's a fresh account I want to read. We look for its location with the account index. So once we know this index with its location, we now pick the reference from the most recent slot and then read the data from that location in the account file. Don't forget, it stores. Let me see if I can try to represent what this is in Excalibur. Excalibur. Let's try to represent that in Excalibur. All right. So when we have a hash map of, let's do a pub key and try to use JavaScript to explain this. That's why not. Yeah. and I want to increase the size of that actually, not that large. All right. So we said it's a hash map of an address pointing to. I'll try to use JavaScript first then. So like an object, yeah. This is the key and this is the value. Then inside it we have, what does it say? Inside it, this is the key. The value is an array, a vec, an array of slots, file ID, and file offset. So we have slot, file ID, and file offset. Uh, pub key is point. Where was I? Excluded row. Oh, sorry. It's pointing to. So now it's pointing to a vector, an array rather. Pointing to an array of a tuple, and the tuple is slots. Let's say slots 105, 102, whatever. Then the file ID. Let's assume that is inside account slash 102.34. Let's assume that's the file ID. Then our offset is at offset 40. Offset one account. Let's assume that is one. Then I have another slot 101. Then accounts 101.1. Then that one is inside. That's an offset of 80. Then we have, and so on, and so on, and so on. So this is what that magic code is trying to explain. This is the key, and this is the value that it's pointing at. So if we're looking for the details of this account, we would check. Once we know this account, we'll now read for the earliest slots, like the latest slots rather. Check the latest slot to know what slot it's in, then the account file, then where do we start reading from. So once we have that, we can quickly use the mmap, check to see what what details are inside this account when we know all of these three things. So essentially that's what it looks like. um I'm also going to check the code to confirm that. Well, so I keep going there. So many accounts around me. Just come here. We've passed all of this. We're at already an account. Okay. Data can be directly interpreted by Validator as an account structure. Okay. Writing accounts. Another key component of AccountsDB is tracking the new states, new account states. For example, when a validator processes a new block of transactions, the result is a batch of new account states at a specific slot. These new states then need to be written to the database. So this is written to the AccountsDB eventually after it has been routed. But doesn't talk about it right now. We might get into it, or we use Prince's book. The two main steps for writing to this account include writing the account data into a new account file associated with a slot, then updating the index to point to the location of this new account. So just append a new slot to the array, to the vec. So once we have a new slot, we append. Also, append if it's pushing, then this should be 101, 102. Let's assume it's a queue. Okay, queue is 5 for now. First in, that's queue. So if it's a FIFO queue or a LIFO queue, anyhow, it's not that it just gets the first the most recent, that's the latest. Sorry, I keep saying recent. The latest slot number and gets the state of the account. That's to write to. Uh, okay. Background threads. A new account state As new account states are written to the database, we must ensure memory is used efficiently by performing four key tasks. That's flushing, cleaning, shrinking, and purging. Okay, flushing. To reduce memory requirements, data is periodically flushed from RAM to disk. So, like what I was trying to explain, that if if a slot has been rooted, the data is flushed from RAM to persistent disk. That's where you now have a file for that. It will move from the cache to the actual file. So we have a it's an account here. We can have a file like so. Yeah, this is now a persistent account file for that slot. But previously, it will not be written immediately. It will still be in the RAM. For example, the index's RAM-based hash map acts as a cache. So that's a cache for recently accessed data. That is, if a data has been read, there's a read cache. And when that data has not been used in a while, it is flushed to disk to make room for more recent account indexes. Another example is how new account states are first stored in RAM and only flushed to disk once the associated slot becomes rooted. Okay, this is the one I was talking about. Once the associated slot becomes rooted, yeah, this one is for reading. If it's reading an account, if it reads an account once, then after a while, if that account is not fetched anymore, it's flushed. You just flush that back to disk. Then another example is how new account state are first stored in RAM and only flushed to disk once the associated slot becomes rooted. So rooted means if there's enough evidence that this slot is final, then that's when we say slot is rooted. Yeah, kind of keep up with the charts also. See if we have any questions. Am I even audible? Okay, okay, I think we're good. Uh, so let's get back to think about what we're doing. I can't set up a solid RAM flush this. Blah, 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 blah. Okay. This approach reduces the number of slow disk writes, only writing rooted data. Yep. Like I already talked about that one too. Cleaning. In order to limit memory growth, we must clean old data. For example, if we have two versions of an account, one at slot 10 and another at slot 15, and slot 15 is rooted, that means it will not be rolled back. I mean, it is final. We've talked about it, we've gone over it a million times, and we are now confident that this is rooted. This slot cannot be rolled back. Then we can remove that account and index data corresponding to the account at slot 10. Essentially, if we have if slot 101 is rooted enough, if slot 101 is rooted, then all of this will be removed for more space to be added, for more space for more accounts, for more indexes, essentially. So that's what it's saying. If slot 101 is rooted, this other ones will be removed, and we have just new ones piling on top of that. Then once plus 102 is rooted, 101 will be removed, and all and all and all. Because there's no use having all of this in RAM or in accounts DB where there's a ledger. So it's that what we're talking about the ledger. So ledger is the final uh old faithful, I'm going to say, source of information for the network. But for real-time information like written data, fast access to info, we use the accounts DB. Yeah, so let's keep going. It's just interesting now that I think we've broken some ice and we're now comfortable with the topic. Last week was not like this. We're just reading and trying to break things down, but I think we understand it now. I understand it better now and I can explain it better now. Let's keep crushing it. How are we? Okay. For example, if we have two versions of an account, okay, we talked about this already. Another example of cleaning is when an account drops to zero lampot, in which case we can delete the full account. Yeah. So the cleaning phase wipes out index entries, but it does not reclaim the region of storage in the account file that was occupied by the account's data. After cleaning, this region is considered garbage data in the account file, which wastes storage space and network bandwidth. So yeah, 1 minute says so that's cleaning. So after cleaning is when excuse me. After cleaning is when shrinking can be done, I think. Yeah. Slot 10 is rotated, but we need to keep both accounts. In the case of fork after slot 10, we talked about forks. Yeah, like I gave a quick explanation about forks when we started. Account 0 at slot 10, account 0 at slot 15. When slot 15 is routed, we can delete slot 10 data, but slot 10, the space that is occupying in the account index still holds. Yeah, so it's garbage data now. Then shrinking. After accounts are cleaned, account file will contain alive and dead accounts. Where dead accounts have been cleaned, yeah, and therefore no longer needed. So when an account file has a small number of alive accounts, when that small number of alive accounts, the alive accounts can be copied to a smaller file without the dead account saving disk memory. This is called shrinking. So it's not essentially like you're deleting that one off. You are going to copy the relevant ones into a new file. So starting a new file essentially without the other account and saving disk memory. So you are creating new files on top of each other. So that's why we have multiple files here, multiple files, multiple files, multiple files. 4063, 4062, 4069. These were different slots, 4021, 4029, 4062. Different slots that had writes in them. And if I'm sure there will be like same accounts here because this test validator and not so many accounts are created to my laptop here, my PC. I think I have okay, chat. Good. Okay. So let's get back to it. That's called shrinking. Yeah, shrinking. Let's see what the diagram says. Accounts are flushed to disk as an account file. Yeah, flushed to disk as an account file. So this is an account file. Header, data, padding, header, data, padding, header, data, garbage. After cleaning, most of the accounts are dead. So after cleaning, this assume this is the rooted one. So all of these are dead. Yeah. So all the details here are dead. This is the most recent one. We copy this to a new file. Dead accounts are removed, and the account file is shrunk. So it's not like we're copying this to a new file. We're creating a new account file for this data from this location. So that's basically what it's trying to say. Uh, Lastly, we can also purge the entire account files for slots which are forked off of the routed chain. You can explain if you you were as a validator, you are building transactions, you are building a block from a previous block that is not routed, that is liable to be rolled back. That means that entire chain will be for it can be purged. So that entire chain will be purged off because you did not build off a chain that was total that the majority of people agreed, majority of validators agreed to continue with. So you're building off of a wrong timeline. So your timeline will be erased. So if one of the branches of a fork becomes rooted, then we can delete all account files associated with the non-rooted branch. So the accounts DB contains rooted, non it contains just keeps opening files. It doesn't care if it's rooted, if it's actually on the right timeline. Let me use the word timeline. I think I relate more with timeline. Doesn't care if it's on the right timeline or not. Just keeps creating account files. Then eventually we will know once the network gets far ahead of it enough, we will know if all these account files belong to a rooted chain or not. So if it does not belong to a rooted chain, all of these accounts are purged, they are deleted. Files, not accounts. Account files are deleted from the non-rooted branch. So this is what purging does. So there's a fork occurs at slot 19. So that is A, B, two forks at slot 19. There's slot 19A and slot 19B. Then someone starts building a transaction from slot 19A when the transactions that are inside slot 19B is actually the correct one. So eventually, when we know that slot 19A and its descendants are forks, we don't agree with them, they'll be purged. Then we'll continue the chain from slot 19B. Yeah. So yeah. Then move to slot 19C and all and all and all. Implementation detail. Having covered the high-level component of AccountsDB work, we'll dive into the implementation detail text, loading from snapshots. Uh, okay, yeah, actually. Snapshot full slot hash .tar.zst. So we can see an example of that one here when there's a snapshot tar snapshot, then the slot was slot 10203. So then were there account on slot 10203? Yes, 10203, I think fork 56. I don't know if it's fork, but let's assume that's fork 56 or not. So slot 10203, then this is the ID, maybe transaction whatever. Let's see, let's keep going. It says hash, transaction hash was that one. The snapshot full slot, then the transaction hash dot tar dot zst. For example, we saw that one snapshot at slot 10 with the hash of this. And an incremental, is it? Sorry. And an incremental snapshot following the naming convention format. Same one, 10 to 25 metals. Yeah. I quickly want us to test this. Okay, let me see if it is from 1 minute, 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 1 minute. Question data buckets, in accounts, writing accounts, writing account. Yeah. When pressing the block, right, the first dash. Bing. Let me see if there's the term cache here. Yeah, exactly. Okay, there is the read cache and write cache, but that is far into the article. We've not got into that yet. You might pick that up maybe tomorrow or Wednesday. Today's Monday, yeah. Yes, today's Monday. But that may be Tuesday, Wednesday. But I want to demonstrate if it's actually true that when you read the thesis I'm trying to prove is, let me read it out. To validate that accounts stored in cache can be queried faster compared to the accounts that are in persistent memory. So that's why I initially created those 5 accounts, because now a lot of slot has passed, and who knows, those accounts may have been moved to uh to the account file, might have been moved to the account file here. These 5 accounts that are created here. So they will no longer be on the RAM of any leader anymore. Yeah. So yeah, this is now one place to start. So what we want to do is want to fetch the account, then what we fetch the account like 100 times or something, 100 times. Then we'll do get the delta P50, like get the average of what it took, how long it took to fetch 50 shots. Yeah, GM, Zishan, I know, yeah, GM guys. So we need to find also, this also fetch to get the data P50, then also send a transaction. By the way, I think it was from Zishan. Zishan also did something similar on Twitter. I think it was the average of transaction times landing on. I can't remember. I saw a tweet about it, so I was like, let me also try to do something similar for this. Nice, the guys in this chat are inspiration to inspiration. Yeah, big one. So let's see. Then we send once we read, we'll know the latency for reading. Then also when we write, we want to know the latency for it. Because when you write the transaction once, it now gets easier to read again. Yeah, it gets easier to read from the transaction from the cache again because it's in write cache. So you check read cache. If it doesn't exist, checks write cache. Then it checks the index for the file. Yeah. So once it's in right cache, it will still be relatively easy to fetch because it's no longer fetching from mmap. Yeah. This one, let's leave this one for now. Close this for now. Let me get an RPC that's not rate limited. Where are you at ORPC? I hope you guys are enjoying what we're talking about, or you're gaining some knowledge, or are getting bored. Let me know in the chat. You're getting bored, you're gaining knowledge, or you're enjoying it. I think it's this account, and I will get the RPC from QuickNode. I use QuickNode for uh I like QuickNode basically. I don't know why, but I like QuickNode. Uh, um 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 Still loading up. Okay, let me sign in. Sorry guys, I should have said this before the call, but we're almost on almost, what's the word again? English is failing me. We are almost late on the clock. Yeah. But let's see if we can. Okay, AI should be able to quickly help us with that. Write all the, or give it enough context and write the stuff that needs to be written. And I will do, what is my RPC endpoints, quick note endpoints, then the RPC. I cannot show you this currently because it's paid RPC. I'm giving out paid RPC. You guys will rate limit. You hit my rate limit quickly. No, no, do not disable this, bro. Uh, my bad. I was talking and I clicked on the wrong button. Multi-chain support. Multi-chain, yes, enabled. Do not disable for, yeah. So now I was looking for Solana DevNet, yeah. And I will copy Solana DevNet, yeah. And I will set that to my environment variables. Solana config set hyphen URL. I'll paste that in. I will enter that. Then I'll clear my terminal. Then I will bring back the terminal. So now we have a, oh, no problem. Let's do that. Uh Codex. Let's use codex. Let's suffer codex a bit. I I want you to write, I want to write a Rust script that, what does it do anymore? Uses this 5 accounts in the harness. Did we create the accounts? Yeah, yeah, I think we did. So let me just copy. 1 minute. Let me ls anything that has the JSON. Yep. Let's copy all of this and paste it into, yeah, all of these 5 accounts. Are we good? Are we good? Okay. All of these 5 accounts in a harness, and what it does is we aim to, one, validate that Let's validate the speed of reading and writing to accounts DB. We want to validate the speed of reading and writing to accounts DB. First, read the account 50, let's do, yeah, 50 times, let's do 100 times, 100, 100 times. Can my RPC support 100 requests per second? I don't think it can. Let me see what's it maxed out at. Uh, Pricing. Sorry guys, coconut pricing for 50 requests per second. Okay. Okay, we'll do 50 requests per second then, no problem. We want to first read the account. Let's do 45 times, 45 times, and record the delta P50. Then delta P50 for response time. For response time. Then second thing I want to do is record the P50 second time. Then write to the account once, i.e. send 0.01 so from some key pair .json to the current account. Once you send 0.01 so from the pair .json to the account, then read 25 times again. I think that covers everything. Send fetch an account, get data, send transaction involving the account, delta to the amount of the recorded data 50. Okay. Then and get the delta P50 also. I want you to use all multiple threads for this. Do you want to use multiple threads? If I'm using multiple threads, then don't use multiple threads. Use a single thread. If I'm using multiple threads, then I'll be doing 25 times 5. That's on 25 times 5 is 125 requests per second, and I can only do 50 requests per second. So I wanted to use a single thread, since I can only do 45 requests per second on my RPC. Do you understand? This should be in Rust Tokyo. I think it should be in Rust Tokyo. Make a plan. Shift tab. Make a plan. Okay, so I can go through this plan. So let's finish writing the plan, and once it's done, we check it out Once more. Then we would test also. Is it done with the plan? No, not this one. Three choices. What three choices do you need? Are you still thinking? Is it done? Spit out the three choices. Let me know when you're done. Uh, for is yeah thing. Uh, and we are going to do. Why is it still? Uh, why is it still? The, just still thinking about it. Mm, I said I found Quasar, Solana Rush program plus a DevNet test setup. There is no existing AccountsDB benchmark harness. I plan this as separate okay with source guides. Keep the request. So go ahead with it, bro. So why this stop? Are you done with the plan? Or did I stop it? I don't think I stopped it. Harness or customer PC configuration. I plan this as a separate Tokyo based Rust benchmark client, keeping all request request area. To make the plan decision complete, I need three choices. You want the five account run aggregated. This affect the benchmark by so I'm pinning them down now. Run each serially for each account, 45 reads, 10.1 so transfer, then 25 reads, total 350. Let's make them 45, 45. Sorry, my bad. Let's do 45, 1, 45, 45, 1, 45. Yeah, I'll provide provide the ERPC in ENV. Yeah, required CLI flag, require RPC. So the same code can target your account to be harness or any related RPC. I will provide environment variable. I already said this. Yeah, report P50 latency for both read phase and after minus before in millisecond per account and overall before, after, and difference. Yes, yes. Individual letters. Yes. So let's see what it will come up with now. Five cell account 45 1 45 reads. Human table JSON recommended. Print a concise terminal table. Human table only. How do I need JSON for? What do I need JSON for? Let's do JSON. Start after the RPC report confirmed. Usually a good speed consistency balance for an RPC benchmark. Uh, when should post transfer read begin? Yeah, confirmed. I give. Don't care about that anymore. Okay. Kill off the camera. Okay, let me read what it said. And said create a standalone ROS2 benchmark client that serially benchmarks all five supplied accounts using the sequence five get info the account info read, one so transfer the account info read. We use RPC cap all RPC traffic as for 5 requests per second and wait for confirmed setup before post read. Add a separate ROS binary create at even the existing some new accounts on chain signature include some key pair at the center. Require RPC reject RPC. Use Solana's async non-blocking RPC client to single Tokyo for each recipient time each send. Let me check the balance of some key pair first. Solana account, I think key, some key pair, Jason. Solana account, then I'll do a Solana address for this guy, then do that should solve the problem. Yeah, so we have 0.4, so I want to transfer 0.01 to 5. Yeah, that is more than enough. I think we are good to go with this. Yes, implement a plan. Make me proud. Let's see. I will create a not here, not here. I'll create a .env file in accounts test. Yeah, and I will pour in the env 1 minute. What it's calling it? RPC URL is something. So I will give me a minute. Do this right now quickly. I'm gonna quickly pour in the RPC. I will copy the RPC. I will copy the RPC URL and I will put it right here. Once I'm done with that, I'll close this up and I will bring this back to you and you will see it's like nothing happened. Muhahaha. Uh, sorry about the laugh. I bring this back up here and there. We now have an RPC in.env file. So let's wait for whatever this is doing to do. How long does it take to? Can I speed up this video? While we're waiting on that, let's see. Cargo tests. May I download the crest? I don't want to use cargo test for crates. Let's see. So tomorrow we'll be going over how to we tried reading one account file. We tried reading an account file based on the account index that we know should be like. You will check how an account file is, what the account index looks like in Agave repo. You'll try to use that to deserialize an account file and see the details of an account file. So that looks interesting. Tomorrow, it should be tomorrow, Tuesday. Yeah, why not? Yeah, tomorrow. Tomorrow is good. Still have a long way to go. We're still on accounts DB. There is the TPU, the TVU, there's voter, there's rotor, there's turbine, if you want to look at turbine. But there's a lot of components inside Agave. I'll take it one step at a time. My cat just shook my camera. I don't know if you can still see me. Let me see. If I can see. Okay, I'm still. Yeah, camera still works. Unit test pass. It cuts a usability detail from formatting verification. Key path should resolve from this repository, not from whichever directory launches cargo. Okay, let's see. Created a new file called AccountsDB bench. I think that's what it said. AccountsDB benchmark. Okay, benchmark. Uh, so let's see. You can do it, Claude Codex. I believe in you. Do it so I can do it better. Okay, okay. So I will account results by using microseconds, milliseconds. Should do it well. Since we are far from the validator, to go over JSON, over HTTPS or RPC, milliseconds not a problem. Uh, let's try to read what it did. Medium millisecond. What is he expecting RPC as? So let me see if I saved it correctly. RPC URL. Okay, I think I saved that correctly. Space root. And let's get the party started. I 10,000 0.01. So and let's see. But don't break my camera. Implemented the benchmark. Say out okay for 5 run. Also confirmed. All RPC operations are passed at 45 requests per second, print P50 before, after delta, and write JSON results with workspace root key files resolve reliably from representation to RPC are written to output like a code. Validated with cargo tests and formatting diff. To run it, this sends 5 real. This is only just 5. Uh, okay, yeah. So it wants me to run this with I have okay my uh RPC URL is in the env. Just do a set a or whatever and send me the script so I do not paste my RPC in the terminal. Yeah, yeah. Guess if you understand what I was trying to say. The fact is, you just wanted to put endpoints in the command, allow the small runner that exports variables. Now you're talking. You are talking. Uh, So let's see. Yeah, yeah, yeah. So I will just run what's the modifier anymore? I think the env should be inside. If your RPC variable is in a different file. Oh yeah. Okay, okay, okay. That makes sense. So we'll run env file equals dot forward slash dot env v v bash new modifier is AccountsDB benchmark env file bash run AccountsDB benchmark.sh. Let me put this inside quotes. Run AccountsDB benchmark. Then there should be a script inside it. Yeah. Oh, it's not there. We put it out here. Wait, hold on. Let me see what it's saying. Okay, 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 okay. My bad. Run AccountsDB benchmark.sh. Run AccountsDB. Yeah, let's see now. Ah, manifest. Bash run AccountsDB. Ensure that file contains what a similar argument exists. Unexpected arguments manifest found. Bro, did you just write something and not? It didn't validate what it wrote. So let me send this back to it, and we should be good to go. Chatbots, LLMs, they're always sloppy. But yeah, that's why they need a human to validate what they write. Yeah, I think it's a maybe a version mismatch. It's passing manifest path instead of manifest. It's passing manifest instead of manifest path. Let's see if it has put that change in. Okay, so let's try to run that now. Yeah. Muhahaha. Okay, okay, let's see. So I want to validate if what we read is true about the read cache, the write cache, and the accounts files, persistent account files. Why is it taking forever? Why are you taking forever? Did my LLM just scam me? I think I was, yeah, no, not a big deal, not a big deal, not a big deal. Okay, cool. Benchmarking. Okay, and it should give us a response soon. Uh, uh, wait, let me check my RPC. Let me check my RPC provider to see the chaos I'm unraveling here. Yeah, see, check my RPC. No spikes yet. That's last 30 days. Current cycle. Yeah, now I think it's filling it. Let me go into metrics. Not last 30 days. I want 2 minutes ago or something. Performance last hour. Yes, give me last hour. Yeah, we add. I can see the, I can see the charts moving up now. You guys can't see it, but me, I can see it. I think I can share this one. Yeah, my RPCs. My Nah, no worries. When we're done, but I can see my RPCs feeling it. I can see the charts going up. Why is it taking forever to benchmark 45 reads? Okay, no, yes. So wrote it to, and where is my table? Uh, wrote it to benchmark results one.json into account test benchmark results, account test benchmark results. Where you at? Yeah, this one. Okay. Let me tell it to make a table of this data. I can't see a table here. Why did it not make a table? All right. Make a table from the data. Show a table from the data. A an MD would be preferred though. All right. So we did. Let me try to make sense of it before it does that. Parade first time, wow, first time it read your account, it took 959 milliseconds, like that. And after that, subsequent reads were 200 milliseconds, 200 milliseconds. That shows that that's correct, because the account was not in the cache, it was not in the read cache previously. You fetched it once, then after that, subsequent fetches were 200 milliseconds, and all. There was a time we got 680 milliseconds. Maybe that was a new validator did not have the a new validator did not have a new leader did not have the accounts in DB yet. Did not have it in the cache yet. Or maybe that's an outlier. Might be an outlier because every other one is 200, 200, 200, 200, 200. So now for the second, okay, after that, after we wrote to it, it still have 200. Cool. It's now in the right cache, but now we have 222, and okay, every other thing after that was between the 200, 215. Uh, for the second account, pre-read, oh, this account was loaded. Why was it loaded? This one just gave it 200 milliseconds for the first time, and everything was 200 milliseconds. Why was read? Let's see, tune ID 220. Hmm. Oh, I think the problem was, yeah, I know what the problem was. The problem was it was trying to do a it did um a prelam port balance. It got the balance before the instruction. Why do you do that? Try to get the balance. So maybe it got the balance before loading the instruction. It's already loaded the account into the accounts DB read cache. So our test did not go well because of this flaw. I would tell it not to. Please, can you? I see that the account balances were previously loaded, checked before doing the 45 reads. You already uh, messed up the plan that I wanted to see. check how fast I can read from the account DB when the account is not yet in the read cache. So it messed that one up for us. Uh, can you remove that first balance check if it exists in the code? Let me check for it. Let me see if it. Okay, let's see the MD file it created. But we could see first that yeah, we could use this one. Uh, okay. Pre-write states P50. Pre-write for the first one was 2 to 4. Post-write was 2. So once it has written to it for this first guy, it cost it the P50 was 219. Yeah. Okay. Let me try to do it again, and I'll see. Let me confirm if what I thought it did was what it did. Okay, there's no period balance in the RPC current code. The first network call for each account is the first in the 450. Okay. Rebalance is merely copied from that final time response. Okay. Okay, I think it did not do that, but the first one actually showed us that it was late. Yeah, this one. Let's go back to it. Main RS. No, sorry. Benchmark results. See, pre-read first time it was 959 milliseconds. That was good. That's what we should see, that latency there, because it's not in the cache yet. But for pursuit for the account, then for recipient pre-read for the second user, pre-read was 221. That's fast. So maybe it already had this guy in the cache. So later I'll try again after a while, and I'll post the benchmark on Twitter for guys that are interested. Well, yeah, guys, we this is us poking around AccountsDB and what's it called? And proving if I'm proving that we understand, or we can verify, or we can test what we have learned. So thanks for staying. This is the Anchor founder, and thank you for coming to our pep talk. Sorry. Yeah. Thanks, guys. We'll see you tomorrow. I'll let you guys know when we're going live before going live tomorrow. Yeah, might be earlier, so it will cut across major time zones. But yeah, guys, thank you, and this has been the Anchor Founder.